Okay, so reference angles in radians are a little bit trickier than um, than coterminal angles. All right, so it says to draw a rotation diagram, and it's always good to draw a rotation diagram when you're looking for reference angles. So we're going to start with that. Okay, so we're going to go around, and this is 0 pi, and then this is 0.5 pi or 1/2 pi, 1 pi, 1.5 pi, and 2 pi. Now, 2/3, you should know, is between 0.5, between a half and a whole. However, if you are not good with fractions and you just want to be on the safe side, you would just put 2/3 into your calculator and you would get 0.66 repeating. Now, 0.66 is between 0.5 and 1. So it's going to go in this quadrant here. So that is your 2/3 pi. Now, even though we converted it to a decimal, we want to put the fraction on our graph. So remember what a reference angle is. It's the acute angle from the terminal side to the x-axis. Okay, so that means that we would be looking for how many, in this case, radians does it take to get from the terminal side to that x-axis. So we're going from 2/3 to 1. So if I subtract 1 minus 2/3, I get 1/3. And of course, there's that pi there as well. So the answer is 1/3 pi. That would be the reference angle for this. All right, so let's go ahead and look at the next one. Okay, so we're going to start with 11/6 pi. Okay, so we have 0 pi and 0.5 pi, 1 pi, 1.5 pi, and 2 pi. And I'm always going to do that just to let you see what I'm doing. 11/6 is very close to 12/6, which would be 2 pi. So I know where this goes already, but I'm going to go ahead and put 11/6 in my calculator just to see where it would fall. And 11/6 is equal to 1.83 repeating. All right, so that means that it's going to, of course, always start on the positive x-axis, and then it would go all the way around until it got into the fourth quadrant, and that would be 11/6 pi. So again, I'm now going to look and see how many radians does it take to get back to that x-axis. So this is my reference angle in here. And I'm going to go ahead and say 2 minus 11/6 is equal to 1/6. So the answer is 1/6 pi. That would be the reference angle. If we added another 1/6, we would get to 2 pi. Okay, so let's take the next one. Okay, again, I have 0 pi, 0.5 pi, 1 pi, 1.5 pi, and 2 pi. We're counting by halves as we go around. All right, now 5/4 is just a little more than 4/4, which would be 1, right? So it's a little more than 1 pi, but to be on the safe side, I'm going to go ahead and put 5/4 in my calculator, and 5/4 is equal to 1.25. Okay, so where would 1.25 fall? Well, it would fall between 1 and 1.5. All right, so I'm going to go ahead, start on my positive x-axis, and I'm going to end in the third quadrant. Okay, so now and I'm going to just write that down here, that this is 5/4 pi. So if I wanted to go back to that x-axis, I would have to go in this direction, and I'm looking and seeing what is that reference angle there. How many radians do I have to go in order to get back to 1 from 5/4? So 5/4 minus 1 is 1/4. So 1/4 pi would be my reference angle. All right, so let's go down a little bit. Okay, and we'll continue here. Remember, you can always pause at any time to catch up to what I'm writing if I'm writing a little bit too fast. Okay, so here I go again, and I have 1 pi and 1.5 pi and 2 pi. All right, well, again, 13 twelfths is just a little more than 1, right? Because 12 twelfths is 1, so 13 twelfths is just a little bit more than that. But just to be on the safe side, I am going to go ahead and put 13 twelfths in my calculator. And when I divide 13 by 12, I get 1.083 repeating. Okay, so like I said, it's a little more than 1. So that means it would end in the third quadrant. Okay, and now that would be 13 twelfths pi. Well, how far do I have to go to get back to that x-axis? This is my reference angle in there. Well, if I'm at 13 twelfths and I have to go back to 1, if I subtract those, I get 1/12. So 1/12 pi would be the answer. Now, I could always convert this to to degrees first, but I would have to then convert it back to radians because the direction says that it wants the reference angle in radians. All right, let's do a couple more. So 7/9, I have 0 pi and 0.5 pi and 1 pi and 1.5 pi and then 2 pi. All right, so 7/9 is a little less than 1, but it's more than a half. A half would be 4.5 over 9, but that's if we're looking at it fraction-wise. 7/9, if I go ahead and put that in my calculator, 7 divided by 9, I get 0.78. And so 0.78-ish would start off on the positive x-axis, and it would be, as I said, between 0.5 and 1. Okay, and I'm going to put 7/9 pi there. So now in order to find the reference angle, I have to see how far do I have to go to get to that x-axis. So that's going to be 1 minus 7/9 is 2/9 pi. So my reference angle is going to be 2/9 pi. Okay, one more, and this is going in a negative direction. So I'm still going to start here, but now I'm going to go negative 0.5 pi and negative 1 pi and negative 1.5 pi and then negative 2 pi. All right, so 25 divided by 18. So we're going to go ahead and do 25 divided by 18. And as a decimal, that's going to be equal to negative 1.4-ish. Okay, I'm rounding a little bit here because it doesn't really matter exactly where it goes. Okay, so negative 1.4 would be between negative 1 and negative 1.5. So I'm going to go ahead and start on my initial side, and then I'm going to go in a clockwise direction this time because it's negative. And I'm going to go past 1, but not quite to 1.5. So this would be at negative 25/18 pi. And I'm going to go ahead and see how far do I have to go to get that terminal side back to the x-axis to get my reference angle. So I'm going to, now this you have to be careful because these are negatives, but remember we want a positive result. Reference angles are always positive. So I'm just going to ignore the negatives for now, and I'm going to do 25/18 minus 1. And that would give me 7/18 pi. And that would be my reference angle. So it's important to remember reference angles are always positive, acute angles. All right, so you're going to go ahead and do the practice now. Good luck. And remember, we have office hours if you need extra help on this. And also, it's important that you actually try and learn this stuff because you will need it in Intro to Calc if you're taking that next year, or if you're taking math in college, you're going to need that as well. Okay, thanks a lot, and I will talk to you soon.